So anyway, we're talking about the fourth industrial revolution here, beyond some of the stuff that happened many, many years ago, and really defining what industrial IoT means. And in Germany, we talk about platform industry 4.0. It's really all the same thing, but we know slightly different spins depending on what kind of customers you're talking to. So really, what we think actually happens right now is that the digital transformation that is happening in manufacturing is not just about optimizing your production, saving money, but also to create new products that weren't possible before, because now you have technology that enables you to build those new products and changing your business model as a result, right? So it's not just about optimizing your production, but also about offering new products. So in general, what does that look like for manufacturing? So in Germany, there's a professor that has come up with this model. I've extended it a little bit and modified it, but I think it matches pretty well of what our customers are currently going through. Depending on how long they've been at this, you can put them into one of these stages. And each stage adds more value to what you're actually achieving, right? So really, you really want to go through this step by step. I get customers come to me all the time and say, I want to do predictive maintenance. And I ask them, okay, have you started connecting your machines yet? They say, no. I said, well, you need to start there, right? Once you have that sorted out, you need to start sending telemetry messages from those machines. That gives you visibility of what is actually happening. And that is already a huge value add for a lot of customers. They're actually quite happy with that step. But it's really only the beginning. After that, you start understanding the data. You need some OT experts to have a look at the data to actually figure it out. But we have some tools, obviously, that are now available for the first time that will help you make sense of your data. As a next step, then, you start making predictions using AI and machine learning models on that data. Those predictions will allow you to predict the future, maybe only a few seconds into the future, to prevent a catastrophic failure on your plant, or maybe even months into the future to predict things like maintenance that has to happen to guarantee your production line doesn't stop. And then as a next step, and this is all still manual, right? So you're looking at an alarm maybe that is triggered in a system, and somebody will need to open a CRM ticket to look at that machine. But what if you could automate that so the machine optimizes itself so you don't need to do a thing, right? It's fully automatic, and that's what these digital feedback loops are all about. So you're creating an automatic response to a condition that may occur in the future. And if the condition can't be automatically fixed, then you still need to send somebody, right? But at least in a number of cases that we're working with our partners, an automatic response is possible, and then you don't do anything, and the system just keeps running. And then as a last step, after you have that digital feedback loop, then you can start making changes to the way you do business. So for example, you may be a sensor manufacturer, and the sensor manufacturer says, you know what? I'm no longer selling you sensors. I'm selling you scans. And the sensor costs you nothing. You pay me a monthly charge. I give you my sensors, and I guarantee those sensors will never fail. What's that worth to you? And then it starts becoming a completely different business model that you're dealing with. And then all of a sudden, where that sensor gets made and how it gets made is no longer as relevant as it is today, right? Then it's all about that promise that you've made to the customer around the scans always being there. So that's kind of the idea behind what we think the digital transformation is all about. So with that idea in mind, we created a team that I run, and we set ourselves a number of principles for which we adhere to and build products for. So the most important one is it has to be secure. everything we do has to be secure by default. What does that mean? It means security is turned on. Too often today, I come to a brownfield environment, and guess what? Security is turned off. Well, why was that? Because the guy who set up the machine just had the job of getting it working, right? It was not his job to make sure it's secure. And that is something that needs to change. It's a mindset change. And this is a big issue of adopting the industrial IoT where, you know, an air gap is no longer possible because you have to have that connectivity. And by the way, the air gap didn't work, you know, 5 years ago with Stuxnet. It still won't work in the future. It's just, you know, it's not a solution to the problem. The solution to the problem is defense in depth and making sure that each system in your overall, or each component in your overall system is secure, right? It's also important to, you know, realize that not every system should be connected to the internet. If the system isn't secure, guess what? You don't connect it. You find another way of partitioning your network or putting a gateway in front of it. But you just need to think about security all the time. Another important aspect is everything we do is based on openness and standards. The days where Microsoft make their own standards and do their own thing are over, right? Which is a good thing. So right now, we have been working with, for example, the OPC Foundation on bringing industrial standards forward. And I have a little bit of information later on, but again, openness and really bringing industry standards forward, which have to be open themselves and obviously, you know, run by not-for-profit organizations, so they can't belong to anybody. That's really important. It's super important. Then we're protocol and transport protocol and platform independent. That means it works just as well on Windows as it does on Linux. In fact, we do most of our development on Linux these days. You don't need Windows to use Azure. Although it was called Windows Azure for the longest time. That was the craziest idea ever, right? You don't need Windows to use Azure. And it's important not to be set to a certain technology protocol, transport protocol, because for different domains, you have different transport protocols underneath, so you gotta be independent. So what about OPC UA? Well, it's the industrial interoperability standard. That's their slogan. And that's our slogan. I'm part of the OPC Foundation. So what does that mean? So it means a number of things. It's an open standard, belongs to no one. It's extensible, which means that you can add parts to the standard yourself as an end user or as an organization. So if the Fieldcom Group press release today is a good example, where the OPC UA standard was extended with what the Fieldcom Group has come up with to make OPC UA more relevant in the industrial automation space for process automation. And it has security built in, also very important, as I just mentioned. So let's have a look at some of the industrial IoT consortia in the world, and I have a selection of 3 which are pretty popular these days. So in the USA, you have the Industrial Interconsortium. In Europe, really, I mean, it started in Germany, but now it's really Europe. And it's being copied in other countries as well, mainly in Asia. And then you have Made in China 2025. So let's have a look at those 3 for a second. So the Industrial Interconsortium, in a recent white paper, highlighted the fact that for manufacturing, OPC is set. There isn't really any contention here. Similarly, and you're going to get those slides, so you don't need to take pictures. Similarly, for platform industry 4.0, OPC UA has been defined in 2 of the layers. We're working on the others, right? We're not done yet. But at least there's consensus that for the information and communication layer of the reference architecture, OPC UA is set. Right now, we're actually working on the cloud connectivity piece. And again, now that, you know, the PubSub extension of OPC UA has been released, I think on Friday. We're trying to get that in there. And then the Platform Industry 4.0 has a number of consortia it works with, specifically the VDMA, the machine builders, the ZVEI, which is the electronics industry, the Bitkom, which is the IT folks, and then there's also 2 organizations that are kind of contributing to the platform, which is the Labs Network Industry 4.0 and the Standardization Council for Industry 4.0. So you can see Microsoft is actually quite active in a lot of those and actively working on bringing the platform forward. Made in China, again, standardized on OPC UA in October 2016. So this is set. And this is all in recent history. Luckily for Microsoft, we kind of stumbled onto OPC UA back in 2015 before it became popular and started investing in it. And now we're one of the first through the gate, which is, of course, great for us. So one of the things we did is we contributed an open source reference stack to the OPC Foundation. So at the time, .NET Standard had just come out, which is cross-platform. So for the first time, you can run .NET applications on any platform you want, and it's the same code. No if-defs, nothing. It's literally the same code that runs on all of these different runtimes. And we ported the back then reference stack for .NET to .NET Standard and made it available to everybody on GitHub through the OPC Foundation. We certified it for compliance. This has happened recently, so we're very proud that we're certified. And we have a commercial partner with Softing, so if you want to buy the stack and use it in a commercial product without being a member of the OPC Foundation, if you're a member, you get it for free. But if you're not, you can buy it from Softing. And what you're really buying is support. So I recently looked, and we had over 10,500 visitors in the last 2-week period on GitHub, so it's pretty popular. Overall, with this and some other stuff, bits and pieces that we contributed to the OPC Foundation, we contributed over 4.5 million source lines of code so far, and we're not done yet. We're continue to add and obviously continue to make improvements to the reference stack as new parts of the standard come out. So in the ISO OC model, OPC UA is an application, right? So it sits up here, the application layer. And then for a number of the message format and also the message, sometimes the transport, is defined. And again, there is now client-server, which was the original communication model. Now there's publish-subscribe as well, which was just released on Friday. And a lot of folks, there's a lot of misinformation out there right now. I mean, a lot of folks say, oh, you need TSN to use OPC UA. Well, you don't, right? You can use it over anything you want. TSN, obviously, is a data link protocol. Also, TSN cannot be used for OPC UA communication to the cloud. I always say, you can do that, but only if you run a really long Ethernet cable from your factory all the way to your data center. Then maybe. But then within the data center, you're not going to be very happy either. So obviously, TSN is a real-time extension to Ethernet that is local LAN only. So people say, why the hell do you only support OPC UA? Well, what about all the other standards and factories today? I say, well, OK, tell me which one should we pick? And I say, well, I don't know, Profinet. Well, it's 8% market share, right? I say, it's really either or. You either support them all or you support none of them. And you say, well, we got partners that build gateways that translate from a field bus or a Ethernet-based factory network to OPC UA. And guess what? Those adapters are not expensive if you look at the cost of your machines, right? So it's not a big deal. And that's our strategy. We have a partner network. If you have a machine that doesn't speak OPC UA yet, get yourself an adapter, and we're friends, right? So that's the reference architecture that we built. So obviously, we have an edge solution, which we call IoT Edge. Within IoT Edge, you can also run local workloads, either for analytics or machine learning. And we built 2 components. We're working on a few others that we will release at Hannover Messe that offer industry-leading OPC UA support for any cloud platform vendor out there. And then to the right of the firewall, right? So once you go to Azure, it just works. So every Azure service that we have available today just plugs into this system, and we made sure of that, so you don't need to build specialized components on Azure. Azure is OPC UA independent, if you like. All the translation work and all the adapter and configuration work happens on the edge. But we're actually sending OPC UA PubSub data to the cloud. It's a JSON format, so our cloud supports JSON, therefore we are compatible. Again, I already mentioned this. So there's really two things that you need to understand here. One, you need to support both communication patterns to get a full set of features. Client server is great for browsing the rich information model that OPC UA provides. PubSub is great for telemetry. So you need both. And obviously, it has to be done in a secure way. Azure IoT Suite is our PaaS offering. And we have built the Connected Factory Azure IoT Suite. It's open source, and it's a starting point to get you started on what we think a complete end-to-end solution could look like. But again, it's a starting point. It's not a finished product. But it's open source, so you can do with it whatever you want. And we built a white paper to kind of break it down further into how to connect your equipment to Connected Factory. This is the reference architecture. So again, this thing is open source. We have an OPC UA assembly line simulation in there. We have our IoT hub. We have time series insights, which is our in-memory cloud-based time series database. And we built a dashboard. The dashboard looks like that. So we have OEE calculation in there. We have a map of the different locations and so on. So this is something you can have a look at. Again, all the sources are there. So if you don't like it, you can change it. And of course, security was our most important thing. This thing is secure end-to-end, including all these security mechanisms that OPC UA provides. So it's important to have a look at this just as a reference implementation of how security should work. And we have a few gateway partners. This is a program that we didn't advertise at all, right? We started at Hannover Messe last year with two of the main OPC UA vendors, Softing, Unified Automation. And people just keep coming up to me and saying, how can we be part of this program? We want to build Azure connectivity into our edge gateways. Help us. So we said, OK, well, here are the components you need to integrate. And since then, we added 13 vendors in total, and the list keeps growing. Every time I do this, people come up to me and say, hey, how can we play? And since SPS drives, this starter kit is available. Again, with Softing and Hewlett Packard Enterprise, it's an industrial-grade gateway offered at a discounted price, which allows you to really get started because it's the only thing you really need to put into your factory. You plug this in. You need to do a configuration step. We're working on automating that step. And then you're up and running. Global Discovery Server is an OPC UA term for security management, certificate management for OPC UA. There wasn't a sample implementation available. We contributed one. And we just finished building all the source code around that and contributing that in the latest release that we released on Friday at the OPC Foundation GitHub. So check it out. It allows you to do your certificate management automatically, which is a great step forward, believe me. No more USB keys, right, with certificates on them. And of course, we're going to offer a solution that is based on Azure as well. So what do our customers do? Well, Rockwell were actually the first to the gate using this solution before we even finished Connected Factory. So they used some of the ideas and concepts, but they built their own solution based on Factory Talk. And Shell is one of the companies that use this to do operational insights, in close to real time. And the key word here is existing equipment. So you don't need to change your factory or your refinery to hook your stuff up to Azure. That was the most important part of it. And before my time is up, OK, so really quickly, Leutze, They actually use Connected Factory. They're using Insights, HOMAG. They built their own infrastructure around it, so they have a platform that they can offer to their vendors to put into their systems, like they make saws, industrial saws. And then Miele, who have actually standardized an OPC UA and said, if you want to put a machine onto one of the Miele factory floors, it has to support OPC UA. So of course, we have solutions for each step of the way. You can have a look through these in the slides that you will get. So the key message here is we don't leave you alone in your digital transformation. You can come to us and we'll help you with the components of our Azure platform to get you from each step to the next. And that is all I have to say to you today. Thank you.